Hello everyone. In this video lecture, we will be discussing about nanoforms of carbon, Buckminster fullerene, graphene and carbon nanotube, single-walled and multi-walled carbon nanotubes. Nanoforms of carbon. Carbon is considered to be a singular element because of its unique ability to form long chains, whose central core is constituted exclusively by carbon atoms and hence gives rise to molecules which are able to create new materials. Over 3 decades ago, the classical allotropes of carbon, namely diamond and graphite, were enriched with the discovery of fullerenes in the year 1985, which were referred to as the third allotropic form of this natural element carbon. Later on, carbon nanotubes were also discovered. Interestingly, fullerenes and carbon nanotubes are only the tip of iceberg. That is a starting point, I mean. And more recently, a wide variety of new carbon nanostructures are created. Fullerene. A fullerene is an allotrope of carbon whose molecule consists of carbon atoms connected by single and double bonds so as to form a closed or partially closed mesh with fused rings of 5 to 7 atoms. The molecule may be a hollow sphere, ellipsoid, tube, or many other shapes and sizes. Graphene, which is nothing but an isolated atomic layers of graphite, is a flat mesh of regular hexagonal rings which can be seen as an extreme member of the family. Fullerenes with a closed mesh topology are informally denoted as C suffix n, where n denotes the number of carbon atoms. Buckminster fullerene. Buckminster fullerene, which is nothing but C suffix 60, C60, is the most famous member, which is named after Buckminster Fuller, who is the founder of this C60. The closed fullerenes, especially C60, are also informally called buckyballs for their resemblance to the standard ball of association football saucer. Look at this. This is the model of C60 fullerene. That is buckyball. Then the second one is the model of C20 fullerene. These are the models of various other fullerenes: C24, 28, 32, 36, 15, 70. Nested closed fullerenes are named as Bucky onions. Cylindrical fullerenes are also called carbon nanotubes or Bucky tubes. The bulk solid form of pure or mixed fullerenes is called fullerite. Then coming to graphene and carbon nanotube. Graphene and carbon nanotubes both are made of carbon atoms. A carbon nanotube can be thought as a sheet of graphene rolled into a cylinder. Both graphene and CNTs have exceptional mechanical and electrical properties which can often be similar. And we have single-walled CNT and multi-walled CNTs. The picture shows a single-walled CNT of die of 1 nanometer with a band gap of 0 to 2 electron volt. 1 electron volt is equal to 1.60 to 10 power minus 19 coulombs. The thickness of the single-wall CNT is 1 atom thick layer of graphene into seamless cylinder. Their electrical conductivity can show metallic or semiconducting behavior. The bottom picture shows the scanning tunneling microscopy view of single wall CNT. Coming to the multi-walled CNT structure, the figure shows the multi-walled CNT structure. Multi-walled nanotubes consist of multiple rolled layers, concentric tubes of graphene. The interlayer distance is 3.4 angstrom. 1 angstrom is nothing but 0.1 nanometer. That is 0.1 into 10 power minus 9 meters. To describe structure of multi-walled CNT, there are two models are available. One is the Russian Dole model, that is this one. The second one is parchment model, That is the first one. And here, look at it closely. The Russian doll model, we have concentric tubes. As you can see here, we have several concentric tubes available, which is called as the Russian doll model. In the other structure parchment model, it's sheet rolled continuously. Okay. And we have other related structures of CNT also. Depending upon the applications, what we need, we can have different structures of CNT, which are torus, nanobud, graphinated CNTs, that is GCNTs, nitrogen doped CNTs, NCNTs, P-pod, cup stacked CNTs, or CSCNTs. Let us look at them one by one. So here actually the first one is torus. It's a carbon nanotube bent into a torus shape, that is nothing but donut shaped CNT, is called as torus. Second one is a carbon nanobud, which is created by combining the carbon nanotubes and the fullerenes. The third one is graphinated carbon nanotube, GCNT, so which is a hybrid that combines the graphite foliates grown along the side walls of multi-walled CNT. The fourth one is nitrogen doped carbon nanotube, that is NCNT. These are used for enhancing the storage capacity of the lithium ion batteries. N doping provides defects in the walls of CNTs, allowing for lithium ions to diffuse into the interwall space. Next one is P-pod. This is a carbon P-pod, which is a novel hybrid carbon material which traps fullerene inside a carbon nanotube. The last one is cup stacked carbon nanotubes, CSCNT, which exhibit semiconducting behavior due to stacking microstructure of graphene layers. So depending upon the application need, we can go for different structures of the CNT.